Yeah.
So we have flashlights.
Laser pointers.
Yeah, that's a terrific prize. Flashlight, laser pointer. We have geek T-shirts, so we'll give these out. I'll start with an easy one, and this is for a double prize. Does anyone know what MATLAB stands for? MATLAB. Me? Oh, you're gonna go ahead.
I was just going to say, can we cheat?
Matrix Laboratory.
Matrix
Yay.
Laboratory. MATLAB, Matrix Laboratory. Very good. Thank you. So we want to make the session interactive, not only to help you learn about using MATLAB, but also so we can give away these prizes we brought with us that we don't want to take back. So we'll be doing that as we go along. As well, we have on each of the tables, I put these light blue forms. There are evaluation forms. If you can do us a favor and just let us know how we did this session, you can write some generous content. Tell us a little bit about the type of work that you're doing. Let us know if there are other sessions that you would like us to do in the future, whether at CI days or at some other campus engagement. Okay? And so what I'm going to do is introduce you to some of the resources that we have to help you learn more about our tools. So MATLAB itself is our base product. It's our main tool really for data acquisition, analysis, visualization, and all sorts of things. And that's what Sumit will be talking about. But MATLAB also has these add-on tools or modules or components. A lot of them are called toolboxes, you may have heard of. So we have the toolboxes for statistics, toolboxes for optimization, parallel computing, which is a hot topic, image processing, and all sorts of things. So some of these toolboxes, some of these topics we'll be talking about during the presentation. But what I want to do is show you where you can get access to more information and resources to learn about these other tools that can and how they can help you in your work. So I'll do that as we go along. By the way, these are, anyone's wondering, this is MATLAB gum. If you haven't had MATLAB gum yet, give it a try. So yeah, I got a strange look. It is actually not, it's not too bad.
It's pretty okay.
Pretty good. Okay, so here's what we're doing today is we're going to do this short session here on essentially introducing you to specific examples on how you can analyze, visualize data through mathematical, statistical, and engineering functions that support common engineering operations. So we'll bring data into MATLAB, show you how you can do that, and even images, perform statistical analysis and curve fitting, look at automating your analysis, and also we'll show you a little bit about publishing as well. We'll talk to you a little bit about that. We have very simple tools, just really a point-and-click interface in our MATLAB desktop, where you can actually publish your work. So we'll talk a little bit about that as well. All right? So I wanted to just briefly talk to you a little bit about some of the resources that we have. MathWorks is about accelerating the pace of engineering and science. We're a commercial company with quite a large presence in academia, especially in engineering, but also in all sorts of areas. We have, as a matter of fact, in Michigan, we have people who are using our tools at LS&A, at the medical school for medical image processing and other things. And so MATLAB is actually a tool that's spread out quite universally at the University of Michigan and other premier institutions. We have, our product set starts with MATLAB. We also have a model-based design tool called Simulink. We're going to focus on MATLAB today. We have over 80 add-on components. They're widely adopted by industry, government, and universities and colleges worldwide. Our advantage really is MATLAB in our tool set gives you the best single environment for your workflow. We're also going to talk briefly about some of the resources we have for classroom and laboratory learning. We have tutorials and webinars. We also have some information I'll show you on classroom and hardware resources and student competition. So I'll just introduce you to some of the stuff where you can find out more about this stuff or how you can find out more about it and learn about it on well. Okay, because obviously we want to get to the tutorial. So here's just a quick screenshot of our homepage. So just to show you, if you go to mathworks.com, this is what you would get. So you can learn about GPU computing and some other things that we're doing. But if you just click on our products and services link, that'll take you to this next page, which is our MATLAB and Simulink product families. If this were live, I could scroll down and you can see all the tools we have on the MATLAB side and then the corresponding tools on the Simulink side. But here we have the MATLAB product family, parallel computing, toolbox, and some of these other tools. As I mentioned, we have these add-on components that do lots of different things. So if you want to find out about a specific tool or what it does, like symbolic math toolbox, if you're doing mathematical You might want to click onto that particular toolbox, or say where statistics or curving or somewhere else. It'll take you to a product page. Just about all of our, I think, our tools have the same template, and there you can get access to demonstrations, tutorials, webinars, all sorts of stuff. So that's where I would go. So people ask us all the time, how do I get up to speed with this stuff? Aside from a training, or say a seminar tutorial session like this. So I would go there first. We do have hands-on training if you want to do that, and we do have a discount for academia. We welcome you to look at that as well, of course. But I think that if you can learn a little bit of what Sumit's going to show you here, and then look at some of these toolbox product pages, you can learn a lot on your own. Okay. By the way, how many of you right now are using MATLAB? A few of you, and the rest of you are brand new to MATLAB, right? Okay. Those of you that have your computers open, you have MATLAB installed? Do you have MATLAB installed? No. Okay. Do you have MATLAB in the back? No. And you do not either. Okay. So actually, this is kind of like what we see a lot when we do our seminars. We have a lot of people that don't have it installed. Sometimes we do seminars at, say, at King, where they have the Windows training room is where the MATLAB's installed on the computers, but otherwise, that's fine. So you'll be able to follow along anyway. We're going to show you some simple stuff that you can get up to speed with very quickly. So going back to the home page very quickly, just want to show you, if you click on the Academia button from the home page there in the middle, that'll take you to this area where there are tons of resources specifically for academia, including our interactive tutorials. So that's another place where you can get started too. So that would be good. Those of you that haven't had any exposure to MATLAB, well, you will have during the session after today. But you can go there and actually learn from the bottom up, or from the basics. We also want to point out that we have classroom resources. Are any of you instructors here at the university? In the back, okay. So there are some classroom resources. We share lots of materials with professors. So if you click on that classroom resources link, you'll get links to code, models, all sorts of tools, syllabi, and other curriculum that we've worked with professors to develop, or the professors have developed and shared with us from universities all over the world, from Michigan, from Stanford, MIT, and other prestigious schools. So that's a great link to look at. Also, hardware for project-based learning. If you're integrating hardware with anything you're doing, that would be great. That always turns on the mechanical engineers and electrical engineers. And then we have user stories there. There's a button for research, an area for research, and a button for user stories. You can learn about how people are using our tools. So that's pretty much it from me. I'm going to hand it over to Sumit. Here's my information. If you can do us a favor as you're going through the session, or when we have an opportunity, I suppose, let's say at the end, if you can just fill out that form. If you need any other information, let us know. We're also going to hang around after this, I guess. If they kick us out, we'll go out in the hallway, whatever, if you have specific questions you want to talk to us about. All right? Without further ado, Sumit. And we have tons of stuff to give away. So
Alrighty.
if we don't give it away, that's fine, but we'll just put it out there. And
Yeah.
take it.
Okay.
All right.
All right. Thanks, Angelo. Good afternoon, everyone. Thank you very much for coming to this session. Sumit, I'm an application engineer with the MathWorks. Just to give you some idea about my background, I have a bachelor's and master's degree in electrical engineering, and with a background in computer vision and computer graphics. And I've been with MathWorks for about 4.5 years now. Talking about MATLAB. I like MATLAB. I love MATLAB. I've been using it for almost a decade. So I'm going to talk to you about MATLAB. I'm going to show you how you can do some basic data analysis with MATLAB. This is an introductory session where you can get an idea about the interface, how you can do stuff here, and then if you want to move beyond this, Angela already pointed out some of the resources that you can use. So in this particular session, I actually want it to be more of an interactive session. If possible, it would be nice if you have questions, ask me. Feel free to stop me at any given point of time. So I will talk about three things. First of all, give you an overall idea of data analysis. What are some of the typical tasks that we do? And then we will talk about, or actually see an example of how to do those tasks in MATLAB. And then after that, I'll talk a little bit about sharing your work with other people. So I'll talk about publishing, how you can create reports from MATLAB. There are other ways of doing it as well. If you have questions about that, I can talk about it, but I probably not go into too many details. So Actually, yeah, let's quickly talk about some of the tools that we use and use for data analysis. How many of you use a tool like say, Excel? Yeah. What about a programming language like C, C++? Anyone? Yeah. What about tools like Photoshop, SolidWorks? Yeah. Anything else that's not here? Statistical analysis, SPSS. Any other tools? Mathematica. Okay. All right. So there are different kinds of tools available to you for doing data analysis. Now, some of these tools are very specific, like Photoshop or SolidWorks. They are designed for a particular task, and it's actually not easy to kind of modify them to do something that you want. It's not easy to customize the workflow. On the other end of the spectrum, you have tools like C, C++, the general purpose programming languages. You can build a really custom application which does exactly what you want to do. But the amount of time and effort that you have to put in is a lot. Somewhere in between, we have technical computing languages like MATLAB, which not only have tons of built-in features, but they also allow you to develop your custom applications. So, and just to give you an idea, just to give you an example, fast Fourier transform. Everyone heard of it? So, when I was in grad school, I decided to write a routine for fast Fourier transform using C, C++. It took me almost a week to write the routine to test it whether it works or not. If I had used MATLAB, there's a single command in MATLAB to do that. Just use one command, FFT, and my work is done. Saves a lot of time. So, let's quickly talk about what are some of the tasks involved in data analysis so that we are all on the same page before I get into the demo. So the first thing that you need to do is get hold of data. The data can come from different sources. Where do you get your data from? Excel files, something? Excel files, text files. You can get it from hardware. It can come from any source. Once you have your data, you want to do some analysis with it. You want to do some mathematical analysis, fit a mathematical model to it. If you're working with images, say for example, you may want to find the location of a particular object in an image. You may want to find the, say the length of a particular object, something like that. Once you have done your analysis, you have extracted useful information from your data, you want to share it with other people. You may write a journal paper if you're working towards your thesis, or you may write your thesis or dissertation. You may just create a DLL or a program which can be used by someone in your lab, someone on the same project. Or you can create a nice little application, a GUI that others can use. You can just sell it to your customers. Now, these are the main steps of data analysis. Other than this, there's a very important fourth step: automation. I'll give you my example. So when I was working towards my graduate thesis 4 or 5 years ago, I had done I'd done research for almost 2 years. I had gathered a lot of data and then did my research. I was always talking to my professor during the process. And then at the end of it, before graduation, I sat down to write down my thesis. And my professor said, you have put in plots for 2 of the data sets. I need another plot for the third data set. Then what do I do? And it was a very complicated plot. It took me quite some time to get hold of the data and create that plot. And honestly, by the time I had forgotten how I had done that. So this is where automation comes into the picture. I had a MATLAB script in which I had recorded all my steps So all I had to do was just change the name of the file and run it all over again to create the third plot. So that is where automation is really important. You should be able to make your process more repeatable as well as maintainable and modifiable. Now, I'll show you with the next example, which is coming up, how you can do all of these things in MATLAB. So the example that I will show you, let me give you a high-level idea about the example, and then I'll show you the files and everything. So I actually have an Excel file, which has, so I have data for, actually, use this. There you go, that works. Yeah, so we have to estimate the power usage based on time of the day and ambient temperature. So we have recorded the power consumption from a power plant for a whole year, and we have to develop a mathematical model which can predict the power requirement based on the time of the day and the outside temperature. Something like this would be useful for, say, a power plant engineer if they want to see how much coal they need to buy for the next week or for the next month. You really don't want them to run out of coal, maybe in winter or peak summer. So what we are going to do is we will see how we can get the data into MATLAB. We will examine how we can examine the different power consumption trends over different time scales, and then develop a mathematical model to fit the data and then predict the power requirements. All right. With this, let's get into MATLAB. And actually, all right. How many of you have never seen MATLAB before? All right. That's why you're here. That's why I am here. So this is the MATLAB desktop. If you double click on the MATLAB icon on your Windows desktop or Mac desktop, you'll see this. It has different panes and windows. I'll talk about them one by one as I use them. Now, the first window that I will use is the current folder. It's just a file and folder browser. So MATLAB always works from a particular folder. So you can change the folder from here. Oh boy. Oops. Actually, I have a tool that zooms into the screen. It doesn't seem to be working right now. Let me try to turn it on once again. Alright, let's give it a shot. There you go. That's better. So MATLAB works on a particular folder. You can change the current working folder or the current working directory from here. This is the current folder in which I have all the files. So the file that we are working with is this one. It's an Excel file. And here you can see the way data has been recorded. So we have power consumption and outside temperature data, which has been recorded in different time scales: monthly, daily, hourly, weekly, and mention some holidays if there are holidays. So we have to get this data into MATLAB and then fit a mathematical model to power consumption based on temperature, and we'll take hour of the day as the other independent variable. So for those of you who have used MATLAB before, how do I get this data into MATLAB from the Excel file? Question for a Flashlight. Anyone? No? No one at all? Okay, let me show you a very easy way of doing it. What are we trying to do here? It's trying to import the data into MATLAB, right? So you can just right click on the file. You have the option right here. Actually, I clicked on it. Import data. MATLAB is smart enough to figure out what kind of file you have: image file, text file, Excel file, spreadsheets, and it will accordingly import data in an appropriate format. So I actually clicked on it, and that brings me to this import wizard. And in this import wizard, I can specify how do I want the data to come into MATLAB. So I can bring all the data in, all the numeric data in as a matrix, or I can bring the data in as column vectors. So if I select that, what's going to happen is MATLAB is going to create variables from each column. All of you guys familiar with programming variables in general? Yeah, understand? Okay. So that is what MATLAB will do. You can control the range as well from here, range of the data. If you want to condition your data before bringing it in, you have some options right here. Say replacing non-numeric data with something. You can do some basic conditioning right here. After that, you come to the last button on the panel, and then it allows you to do several things. You can either just get the data into MATLAB. You can generate a script or a function as well. And those actually allow you to automate this process. So when you're starting up, you can use the click around way of doing your work. As your process becomes more mature, you want to automate the whole thing, you can start using these scripts and functions. Sorry. So I'll do both. I'll do an import data. As soon as I click on that, you can see these variables appear on the pane on the left. I'll quickly do the other option as well, generate a script. Click on that. MATLAB creates this file automatically, which will allow you to bring the data in. I'm not going to save this because I already have a version of this saved that I'm using. Okay, I have the data. Let's take a look at the data. Let's go ahead and double click on it on the top bar. And this is the data from the Excel sheet. If you want to verify whether you got the correct data or not, you can double click on any of the variable names, and you will get this spreadsheet-like interface where you can look at the data. You can go in and change the values of the variable as well if you want. I'm not going to do that. I don't need to for this one. And just expand it once more. You can see that right here, just right here, just by after importing the data, you can you get access to some statistical properties of the data: minimum, maximum, mean, median, mode. You can turn these displays on or off as well. It actually goes up to variance and standard deviation. We have the data, and we have to fit a mathematical model to it. So let's take a look at the data. plot it and see what does it look like, what is the nature, what kind of equation should we use. So if you select one of the variables in this workspace browser, select one of them, and you see that there's a drop-down menu right here. Right now it's saying box plot. See this one? Now, if you click on the down arrow, it gives you a list of plots that you can create with this data. This is the plot browser. I'll just go ahead and select the normal plot, click on that, you have the data. This is how it looks like. Export the graph. Do you want, you mean you want to save it as a JPEG file, PNG file, something like that? Sure. Good question. Thank you very much. Yes. So when you create a plot in MATLAB like this, it is very easy to save it to a different format. You just go to File, can do Save As, and it will allow you to save it as different kinds of files. So that you can use it outside MATLAB as well. And this plot is very interactive. You can do a lot of things here. I'll show you one or two things, and then I'll come back to this plot. So we can see, just by looking at the plot, that the data that we have has kind of a parabolic trend on a very high level, with some bumps here and there. But it goes almost like this. Now if you zoom into the plot, let's see the micro trend. So we have a toolbar right at the top with lots of small buttons that you can use, small tools you can use. I will zoom in just along the x-axis. And you can see that on a very micro level, the data is quite oscillatory. We actually have like 5 high peaks followed by 2 low peaks, and this pattern repeats. So clearly there's something which is causing this this pattern. So just keep these things in mind. So, and we have to figure out why this is happening. So let's take a look at, let's plot the data in different time scales and see if we can find any information from that. So if you want to plot the power consumption, say on a weekly basis, so I select those 2 variables in the workspace in order, and then for this one I will go for a scatter plot. It just puts a point for that data, and you can see that the power consumption varies quite a lot over the course of the week. In the data that we have, one is Monday, so you can see that power consumption is higher during weekdays and lower during weekends. So you can probably fit different models to weekdays and weekends. If you want to do a quick statistical analysis on this, oops, not this. I'll go ahead and select the box plot. in box plot, the red line indicates the median value of the data. So we can see that power consumption is actually higher during weekdays and lower during weekends. So just by creating these plots quickly, you can get an idea about your data. You don't have to spend too much time, say for example, writing code or searching too much. Just from the basic MATLAB interface, you can do these things right away. Let's take a look at power consumption in a couple of different time scales as well. Say if we look at hourly consumption, you can see that power consumption changes quite a lot during the course of the day. It's lower. It's lower during early morning and night, and higher during the daytime, and probably all the factories and offices are starting up. And if you look at power consumption, say on a monthly basis, you can see that power consumption is higher during the winter and summer months. So people are probably turning on their air conditioners or their heaters. That's when you have more power consumption, and less during the rest of the year. There's actually a gap here for October. We actually don't have data for October. But if you remember, we didn't see a gap in the full plot, in the first plot that I created. It was just a plot of all the data. So that is because we had just plotted the data not against a time scale. It was just plotting the points. Now if you want to plot the power consumption on an hourly basis over the course of the year, we'll have to change to a different time format called serial date. It's the format in which computers store their date information, time information. As humans, we are used to hourly, monthly, daily, etc. But computers need serial date. So I'll quickly show you how you can do that. But before that, I've been creating a lot of plots here. What do you do when you want to automate the process? Yes, you had a question.
Not for this data, but for other type of data, can you do a polar plot?
I'm sorry?
Not for this data application.
Yeah.
But for other type of data that they come in annuals.
Yeah.
I use vision.
Okay.
I need polar data.
Okay. Polar coordinates. Yeah, you can create plots in polar coordinates as well. Actually, I don't quite remember which function to use. Let me try and look it up. Thank you. Great question. So just hold on to that question. I'll get to it right now. And yeah. So as I was saying that if you want to automate this process of creating plots, so while we were clicking on those plots, scatter plot, a box plot, MATLAB was spitting out these commands on the command prompt. So this is the second or actually third window we will see, command window. So it's like the prompt of a graphing calculator, for example. You can create variables, you can call functions. So if you want to create a scatter plot for month versus power, you can use this command. So you had a question of polar plots. How do we create a polar plot? So, and I don't know the function to create that. So what I can do is, MATLAB, there's a tool called function browser. So this is the command prompt, and you can see this button here. It says browse for functions. Click on that, and you can start typing the task that you want to do, say creating polar plots, and then MATLAB will come back to you with suggestions on what kind of or which functions can be useful for you. So for example, let's take a look at this one, polar coordinate plot. This is the first one. So you get some idea about how to use it, what does it do right here in the window that shows up. If you want more help, just click on the link, more help, and MATLAB will bring you to this page in the documentation for polar plot. Now, in MATLAB you can call the same, so the name of the function is polar, and in MATLAB you can call the same function in different ways depending on how much or what kind of data you have. So for example, you can just call it like this. You just have to store your the radial amplitude and the angle value in theta and rho, and you can pass it to the polar function. So the documentation gives you all the information about the syntax, and if you scroll down, a good description, tips on how to use it, examples, and there's also a nice little section at the end, see also. So if you're not sure that this is the function that you want to use, you can look at one of these functions as well. Okay, does that kind of answer your question? Okay, so for people on video, if they did not get the question was how can someone create polar plots in MATLAB? All right. So coming back to the original problem we have to convert the date information to serial date format. So I'll go and just go to the function browser. Do a quick search, and datenum is the function that I need to use. Now, I actually already used the function in MATLAB on this install earlier, so I don't need to type the whole command. I can just type the starting of the command that I used and hit the up arrow, and it will bring the command back for me. So datenum was the function. I have data for the year 2006, and I have month, day, and hour information from these variables in the workspace. And I'm just saying that the time starts at midnight every day. So just type in this command, you hit enter, and you'll see a variable called serial date has appeared in the workspace. Now let us plot the power consumption with respect to serial date. And I'll go for a normal plot. Now you can see the gap. If you want to see the values of the variable, right here, just double click on it. All the variables in the sense
Like the original file.
original file. So you can just open up the file from Windows Explorer, or you can just say open outside MATLAB from here,
But together with the new variable.
or together with the new variable. So are you trying to save it to a new file, or just save it in the file itself as well? Okay, so the question is, we just created a new variable. How can we make it part of the existing file? So what you need to do is you need to write the data out. So we have functions which allow you to write to different kinds of files. Um, so just go to data import and export, spreadsheets, Excel, XLS write. So you can use the XLS write function to write the data in a particular location in the Excel file, wherever you want it to go. Or if you want kind of an interactive way of doing it, you can just open it up in the variable browser, and you can just copy and paste the whole thing into the Excel file. Yep. Yes. This one? Oh, that's just a temporary file that Microsoft Excel has created because it is open here on my end. If I close this, that file goes away. This is just a Windows thing. Okay? Yes?
When the data acquisition system doesn't write the files or the columns after each other, it writes them right after another. So
Okay.
I have about 20 sensors, and they're all written one after another. So if I bring that as a text file, can I sort it out with the power of the MATLAB to put them in column format?
Sure.
Right now, it takes me quite some time.
Absolutely. So your question is, you have data coming into an Excel file as row vectors
It's a text file.
in a text file.
It doesn't come in a row. It just comes in one column,
Okay.
20,000, 30,000 data points.
Okay. So it just comes as one big chunk of data,
Correct.
and you want to sort it out and put it separately.
Correct.
Yeah, it can be done really easily. Actually, let me show you an example right now. So just for reference, I'm using a CLC command. It just clears the screen, gives me some space here. So for example, if you have data coming into MATLAB like this, as a matrix, what you can do is, so I just created this variable x, it's magic3. Magic is a built-in function which creates a matrix whose rows and columns and diagonals add up to the same number. So what you can do is you can very easily manipulate data in MATLAB, very easy to index and select data, and then you can set it up in a proper format. So for example, if you want to select the first column of this data, you will do all rows, the first column. So actually, let me show you something before we do that. Say if we wanted to access this number 7 in MATLAB, the way you would do it is the third column and the second row. It's 2, 3. If you want to access the entire column, entire first column, you do all rows and the first column. Whoops. It was small x. I think I've turned on the caps lock. Okay. So with the help of this, and there's a function called reshape in MATLAB. I'll show you reshape in a minute. So reshape will allow you to change the shape of your data in any matrix form. If you want to go from 1D data to 2D data or 1D to ND, that will allow you to do that. It's very easy, just one function call. One more thing that I wanted to show you here was selecting data conditionally. We do that a lot of times. Say if I want to select all the data in this matrix X which is greater than 5. It's a one line command. I'll actually show you, break up the command for you and show it to you step by step. So the first thing you do is you find the location of the data which satisfies this condition. Location is x greater than 5. So wherever that condition is satisfied, you get a 1, otherwise you get a 0. And now if you want to extract those elements, you just do x of location.
Can you do exclusion with text rather than numerical?
Exclusion with text?
I get the data
Yeah,
with the ID of the sensor.
yeah,
Like says temperature, humidity,
yeah,
and then they're going to sequence 8,000 of them.
yeah. Yeah, you can do that. So there are different commands that you can use for that. You can just use something like this. This is actually more for numerical. There's a command called find in MATLAB, which will allow you to find the location of variables or elements based on specific conditions. So you can use that as well. Okay. If I said you can do it in one line. Oops. What am I doing? X of x greater than 5. Oh, sorry. There you go. Small typo. So this is actually a really powerful feature. If you're working, say, in a normal programming language like C, C++, you would have to run at least a double for loop to find the data. In MATLAB, you just need to write one line of code. Okay. All right. Where were we? How far did we go? Oh yeah, we were at this plot. So you can see the gap here. Now, we actually got a lot of information from this particular plot. You get an idea about the macro, the long-term trend. We also zoom into the plot and then we get an idea about the micro trend. How does data vary over short times? Now, it's a very important plot, lots of information. I want to keep it in my report. But if I take a printout of this plot and give it to someone, I tried doing something like this when I was in grad school. I took a printout of a plot like this and gave it to my advisor. He threw it out. What does this plot mean? What have you plotted here? It doesn't make any sense at all. So we need to add documentation to this plot so that it makes a bit more sense. So to manipulate your plot in MATLAB, as I mentioned, there are a lot of buttons on the toolbar. The last one is show plot tools and doc figure. If you click on this button, several panes get attached to your plot, which allow you to modify the plot now. Say, for example, we haven't talked about temperature yet. How does temperature change over the course of the year? That is one of our independent quantities. So what I'll do is I'll add another axis, and then I will plot temperature versus serial date, and there you go. This is how temperature changes. Yes, you had a question? So that depends actually on the function. Some functions have dependent first and independent later, or some functions have it the other way around. You can you can specify it right here. So it's in the order in which you select. You can do that. Actually, you cannot choose it here, but if you go here, and this particular one, the mouse is not working properly. Here. So you have this option to switch. If you think that your plot came out the wrong way, you can switch it right here. All right. So we have both the plots. Let me change the color of the temperature plot so that some different, they look kind of different. Let's change the color. Now both these plots have the same x-axis, so I don't need to put the tick labels in for the first one, for example. So I'll go ahead and delete the tick labels. And let me put a title. Data from 2006. Something going on here. The y-axis is power consumption in megawatt. For the second plot, it's the temperature and Fahrenheit. So I add some documentation. Once you're happy with the plot, you can just go ahead and close the plot tools. This is the button right next to the first one. There you go. Makes a lot more sense now. Now we can take a printout of this and give it to someone. They'll know what's going on. Now, I keep talking about automation. I talked about automation earlier. Now, what if we want to automate this process? We have done quite a lot of things here, but if we want to recreate this plot for data from a different year, I don't want to go through the whole click around thing again. So MATLAB gives you an amazing option which allows you to generate code for this plot. It is a bit different from macros. So have you guys used macros in Word, Excel? It's different from that. When you're recording macros, Word or Excel will actually go ahead and record every mouse click or button click that you do. MATLAB is a bit different. In this case, MATLAB is just going to look at the final state of the figure and will give you the code to get up to that state. This is actually a really good way of learning MATLAB as well. So this was a function that was created. Now, a couple of things I want to point out here, actually 3 of them. First of all, there's tons of documentation here, a lot of comments here. So you know exactly what MATLAB is doing and what are the steps MATLAB is taking. Secondly, you can see the functions that MATLAB is using. So if you want to learn MATLAB, you can just highlight one of the functions and just hit F1, or go to help on selection, and you can just go to the documentation where you can learn more about the function. Second important thing was this file is independent of the size of the data. So all that you have to be careful about is that the data has to be in a vector format. there's no limit to how big the vector is. So right now I think I'm using vectors which are about 8,000 elements in size. This function will work even if the vector is 80,000 elements in size. No issues. And the third really important thing is you can customize these files. You can, there's no restriction on you. You can just go ahead and make any changes you want. Say, for example, if you look at this figure, you see the labels for time. They are serial date. But for us, it doesn't make any sense. What does this number represent? 7.329. It's actually a proper date. So the code that was generated is going to recreate this figure. But what I did was I went ahead and made some changes to the file, and let me actually pull it up. The yearly trend plot, and I just added this command to change the tick labels. That's all I did. Actually, I added one more command called link axes to link the two axes together for zooming. Actually, let me show you one more thing here. I'll just go and save this one to give you to show you one more nifty feature in MATLAB. Say a lot of times when we are working, we may have multiple versions of a document. So we work on a document, then we make some changes, save another version of it, we make some more changes, we save a third version of it. By the time we are close to the fourth or fifth version, we don't know what changes have we been making, especially when you're coding. MATLAB has a very nice comparison tool. Say for example, let me compare this auto-generated file with the file that I have in my folder. So I just highlight those two files in the folder browser, right click, compare. And you can see, you will be able to see the difference in the two files. So some of these are some superficial differences, the difference in the name of the functions. And this is where are the major differences. Just one small thing that I wanted to show you guys. Okay. Hold on. Which ones? Oh, I think the red highlights mean there's a difference in the same line of code, but I think the green one or the yellow one means that these are the extra lines of code. If you want to make it a bit more compact, you can hide all the lines which do not have any changes. We just see most of the lines which are they have changes in them. Any other questions on this before I move on? Alrighty. So we have been doing a lot of things here, and if we try to remember what we have done, especially when you're working on a large project, it can become difficult. I would forget what I did before lunch, so it can be annoying if you just forget what you were doing. So MATLAB has this tool called command history. MATLAB remembers the commands that you have been typing in the command prompt. So what you can do is, when you are done with some basic data exploration and you are confident about the route that you're going to take, you can start documenting your work. You can start creating files. So you can just go back to the command history, and you can select some of the commands that were important for you. I'm just using Control and Select. um, say this one for example. You highlight the commands, you do a right click, and then ask it to create a script for you. Create a script. MATLAB puts it in a file like this in the editor. So script file in MATLAB is just a text file. You can open it in a text editor, in a standard text editor. It just has an extension of .m so that MATLAB recognizes this as a file in which there are MATLAB commands. Yes, you had a question?
While you are here, could you explain a little bit more about what is serious date for example, what's 2006 for?
Oh, 2006 serial date? Okay, okay. So the question is about why am I using 2006 here? So the datenum function, you have to specify the year. So I'm converting my date and time information to serial date. So I need to specify a year for which I'm doing it. So that is why I have 2006 there. And I have month, day, hour. So there are different ways of using the same function. I'm using this particular signature. Does that answer your question? Okay. So coming back to the script, I'll just expand it. Expand the window. So you create a file with a .m extension. You start typing things in. These are MATLAB commands. Documenting is a good practice. So if you want to write comments, you use a single % sign. Something like this. And you can keep commenting it and have detailed and verbose documentation. I'm not going to go into too many details. What I'll do is I'll take out the big script that I was working on, and that will give you an idea of how you would typically write a script which captures your workflow. Actually, like this. So keep documenting your work. Now I mentioned that you can write commands in here. If you use a single % sign, you can write a comment. If you use a double % sign, you can create a cell. Now, cell is a really nice tool in the MATLAB editor. It allows you to do a lot of things. So I'll just highlight 2 or 3 of them. First of all, if you create a cell in MATLAB, it allows you to divide up your script into chunks. Now, why would you do that? So, first thing being, if you want to run the commands in a MATLAB script, you can use this green arrow key. Just click on the arrow and the script runs. All the commands are going to run. But if you are developing a huge application and you just want to work with parts of the script, you don't want to run the entire script. This is especially true when you're debugging your workflow. You can just highlight a particular cell, and then you can use one of these buttons to evaluate the script in a cell-by-cell fashion. So you just want to repeat one part of your workflow to test something. I'll show you an example. So that's how you can set up your script. MATLAB allows you to kind of collapse the cells as well, so you can get a high-level view of what is there in a script. So in this case, some introduction, and then you have importing data, pre-processing data, initial exploration, visualization, surface fitting, etc. So I'm going to expand the whole thing, clear everything out. Oh, just let me talk about one small thing, and then we can start running the script. If there are some commands in MATLAB that you run on a regular basis, for example, I like clearing my workspace, I like clearing the window so that I can type in more commands, then you can keep those commands inside shortcuts. So for example, this particular shortcut CCC, it has these commands which just basically clear everything up for me. Okay. So everything is clear, nothing in the workspace, no variables and no commands. Let me run this script now. So let's import the data. So this file, import data from file, this is another script that was created automatically by MATLAB. If you remember the import tool, it automatically created a script. This is that script. Open this. This is the command, and these are the commands in there. I modified it a little bit so that it accepts the name of a file from outside. So this is how you can modify or customize your workflow. You can call one script from another script, and you can make these changes. So let me run this. You can see I have the data in the workspace now. Then I just add some nice labels for the plots. These are some of the plots that we looked at. We didn't look at this one, but just a plot of power consumption on a daily basis over the course of a month. Box plot, we saw this earlier, power consumption over a week, over the course of a year. And then we converted to serial date format using datenum function, run that, and then we created this plot. Oh, so after making those changes in the script, you can now see the labels have changed. Now they make sense. August of 2006, June of 2006. Now, at this point of time, we have done enough data exploration, at least the initial part of it. We can start and fit a mathematical model to it. So what I'm going to do is, I am going to fit a mathematical model to part of the data. So I'm going to subset the data. I will take data from the months of January and July, which give us good temperature extremes, and I'll fit a model for the weekdays in January and July. So I talked about how you can extract data conditionally from matrices in MATLAB. I'm going to use the same concept here and find the location of the data where day of the week is less than 6, weekdays 1 to 5, and the months are 1 and 7, January and July. So I find the location, and then I use the variable lock in the variables that I have the data in, hour, temperature, power. Extract the data. Now let's do the fitting. So before I get into the automatic fitting part of it, I'll show you how you can do it interactively. Any questions till now? Anyone? All right. So as Angelo mentioned, MATLAB and Simulink are our flagship products. But other than those, we also have a lot of toolboxes or components which extend the functionality. So just click on the start button on the MATLAB desktop, and that gives you the list of toolboxes that are installed on your computer. Actually, I have pretty much all of them. So there's different kinds of toolboxes. If you're in controls, your control design toolbox. If you're in more in mathematical domain, your statistics toolbox, optimization toolbox, global optimization toolbox. If you're into genetic algorithms, neural networks, we have signal processing toolbox, filter design toolbox. Depends on what you want to do. Finance, financial derivatives. So I'm actually going to use the, sure.
Is there a finite element analysis?
Finite element analysis.
In the toolbox, any of the toolboxes?
There is something on FEM, but I'm not very sure if it is on it's in a toolbox or not. Let me quickly check. We do have some amount of it. So partial differential equation toolbox that has some amount of FEM in it. So you can use that. But if you want more information on this, we can talk offline as well. So as I was saying, we have to fit a curve to it. So I'm going to use the curve fitting toolbox. So to do it interactively, I'll use the curve fitting tool. This thing can be automated. I'll show you how. So almost every toolbox that MATLAB is associated with that we make, we also have an interactive tool like this, which allows you to do things interactively in the beginning, and then ways of automating it. So, like for example, in this one, curve fitting tool, there's nothing much to do here right now, but I will select. The first step would be to select the data, the dependent and the independent quantities. So the independent quantities are hour and temperature, and the dependent quantity is power. So I select those variables. So x and y are my independent quantities. Z is the dependent one, which is power. Select the data, and then I select a way of fitting an equation to it. Custom equations, interpolant, lowest, etc. I'm actually going to use a custom fit for this because we have an idea about the nature of the data. So let's go ahead and do that. I will actually load an existing session that I was working on because I'm using a very complicated equation. Cannot remember all the terms. All right. So the equation that I am using is this. Let me explain the equation a bit. So if you remember, there was a long-term kind of parabolic trend. Those are taken into account by these quadratic terms. And there was an oscillatory part of it as well. If you zoom in, I'm taking care of that by using the first few terms of the Fourier series. And I have mentioned x and y as the variables. X, I think, is hour, y is the temperature. So we're saying the temperature is contributing to the long-term trend. And A0, A1, B1, A2, B2, they are the parameters that we have to calculate. So we give the tool the equation, and all we have to do is click on the fit button. And the tool will calculate all the parameter values and then come back to us with this plot. You can get an idea of how good the fit is. So that was the visual aspect of it. Here you can see the values of the coefficients with 95% confidence bounds. Some goodness of fit measures like the sum of squared errors, R squared errors, things like that. So you can use this as one way of comparing different fits. And then if you want to automate the process, this is all interactive. As before, we go to File and Generate Code. You don't have to remember any commands till now. In fact, even after working on it for a while, you don't have to remember any commands at all, unless you're going to start, if you want to start customizing things. You can just generate code, you can copy and paste things from here and there, and you should be all set. So I'm actually not going to generate code for this because we're already using it in this main analysis file. So the function that was generated was create surface fit, and again this is a generic function. This is totally independent of the data. You can specify different data in these three variables, and you will get a different model. Okay. So.
What's the maximum number of variables that you can put in to create a surface fit? You have 3 of them in there. Can you add another one, or how many can you add?
So for surface fit, so this particular tool does not allow too many variables.
Okay.
If you want to go beyond that, we have this function called fminCon, which allows you to fit a function of as many variables as you want, basically. So you get hold of this function, you pass the data to the function, and let me run this line of code. And we get back the same fit that we saw earlier on the big tool. But now this process is automated. Right. Now you'll notice that this function has some outputs as well, goodness and model object. So model object is the actual mathematical model that you can use for predicting power consumption, and goodness is the goodness of fit measure. So for example, if I come back to the command window and type goodness, see the same values that we saw in the tool. And then if you want to predict the power requirement, you use the model object. Say for example, I want to find out how much power consumption, I want to predict the power consumption at noon when the outside temperature is 75 degrees. Specify those values and run this line of code. Says that the power consumption will be approximately 85.5 megawatts, give or take a few megawatts. If you want the confidence bounds as well, let's go a bit, one more step. Right? So you can quickly see, how quickly we were able to import the data from an Excel file, quickly create plots, just 1 or 2 clicks of the button of the mouse, and then how quickly we were able to document the whole thing, create a big script. Now we can share this script with other people, who may be doing similar work, or maybe our project partners or lab partners. Yes. I think so. Actually, I'm not a math guy, so that's why my answers may be a bit vague in that area. But actually, let me show you how to get to it from here. So you go to. So the question is, what kind of functionality we have available for statistics? So we have a statistics toolbox, which can do a lot of these things. A lot of statistical analysis and processing. What I would recommend is you go online, and we have lots of demos and webinars which that you can watch to see what are the things that can be done with this toolbox. One more thing you can do is you can go to the help documentation, and you can go to functions. So yeah, we do have descriptive statistics and lots of things going on here. Oops. Okay. So coming back to the script that we have, let me clear everything out. So now we are at a stage where we have done a substantial amount of work, and we are at a stage where we can start sharing our work. So you can just copy and just give the script to someone, and they can do the processing for data from 2006. If you want to do the processing for a different year, all you have to do is you have to change the name of the file here, and the same processing will be repeated for a different data set. If you just want to share your work as a report or a file, you just have to click on this button, publish. If you click on this button, MATLAB is going to go through the script in a cell-by-cell fashion. You remember I was talking about cells. There's one important thing about cells, one last thing. The MATLAB is going to go through the script in a cell-by-cell fashion. It is going to run all the commands. It is going to take screenshots of all the figures that come up. It's going to take all the comments that we have written. It's going to come back to you with a report like this, with table of contents, hyperlinks to different parts of the report, some beautiful screenshots of both 2D and 3D plots. Exciting? At this point of time, I usually get a standing ovation, you know. So you can create reports in different formats as well. I've just created an HTML report. You can create Word documents, PowerPoint slides, PDF, LaTeX, different formats. Has anyone used this feature here? No, haven't. All right. Yep. Do we get all the fonts in PowerPoint? That's a good question. I'm sorry? Oh, okay. Yeah. Yeah, absolutely. So what you can do is you can use LaTeX markup in cells as well. So if you see this, you see this equation? Yeah. They should be. So these are LaTeX markup. So if I think PowerPoint supports the LaTeX markup, they should show up. Yeah. So you can actually do a lot of things, formatting things in the report. You can add bullets and lists and have equations, HTML markup, images, custom images. You can do a lot of customization right here, and this is part of base MATLAB. Okay. Any other questions before I move on? Alrighty. So this was pretty much the demo that I wanted to show you guys. Just to do a quick recap, if I can find the pointer, I cannot. Okay, that's fine. So to do a quick recap, we got data from an Excel file into MATLAB. We did some analysis with it. We created some quick plots, and we fitted a mathematical equation to the data, and we predicted the power requirement, used that equation, and then we created a report that you can share with other people. Now, just for your reference, the toolboxes that we used for this demo were statistics toolbox and curve fitting toolbox, and MATLAB is the base product, obviously. Just to give an idea about the other kinds of things we can do, we can get data from pretty much any kind of hardware or software you can think of. Out of the box, we support different file formats, different databases, different kinds of hardware. If there's something which is not in the list, we give you the capability to write custom hardware or interface with hardware or software via API and drivers. We have lots of toolboxes, almost 80 or 90 of them, that you can use to do the processing and visualization. Different areas of like signal processing, computer vision, communications, etc. Sharing, you can create reports like this if you want by using MATLAB Publish. If you want more customization in the reports, you can use MATLAB Report Generator, by which you can create tables and other fancy report components. You can also create DLLs out of your MATLAB code. You can create GUIs to make your code or your application more usable and portable. Yep, that is pretty much it from my side. I think I finished pretty much on time. Do you guys have any questions? All right, thank you very much. I'll be here for a few more minutes while I wrap up. So if you have any questions, specific questions, feel free to come up and we can talk about it. Thank you very much.